All right, Precalc, this is where it gets super fun. We are solving equations, but this time we're solving trig equations. So we really have to get back to that unit circle. Think about that unit circle. We are in lesson 5.3, and our essential question is, how do you solve trig equations written in quadratic form or containing more than one angle? So the first thing I want you to do is pull out that unit circle. And let's take a look at what that unit circle is telling us. Now, we're going to look right here at example 1, and it's just telling us to find all the solutions of this. So just like you would do in Algebra 1, we're going to go ahead and add 1 over 2 cosine of x is equal to 1 and divide by 2. So I'm learning that the cosine of x is equal to 1/2. But if I look at a unit circle, the cosine of x is equal to 1/2 in a couple different areas. So let's talk about where the cosine, the x, is equal to 1/2. So I know the first place is right here at pi over 3. So I know that this is 1/2 in root 3 over 2, but we are just looking at the cosine. And then x is also a positive 1/2 at 5 pi over 3. So that's about right here. So remember, when I travel this, that was pi over 3. When I travel all the way around, this is 5 pi over 3. And this is also a point of 1/2. Now, we have to tell our answer that every rotation around the unit circle is going to be that answer, meaning I'm not going to write every single one. So what I did here, as you can see, is I showed my pi over 3, but what I did is I multiply. So if I went one trip around, if n was equal to 1, then I know that at another 2 pi. So right here, we know pi over 3 is an answer, but when I travel around again, well, that's going to give me 7 pi over 3. When I travel again, that's another 6, so that's 13 pi over 3. So again and again and again, whether n equals 1, n equals 2, or n equals infinity. So we have to be exact in our answer by showing 2n pi. So my other answer was 5 pi over 3. And because every trip around the unit circle is going to land where cosine is equal to 1/2, I also have to put in that 2n pi. So my final answer is right here, pi over 3 plus 2n pi, and 5 pi over 3 plus 2n pi. So yes, we do need to know our unit circle. The other wonderful thing is that sometimes they give us intervals. So this one's saying, hey, we're just looking in the unit circle, so you don't have to go ahead and state those 2n pi. So let's go ahead and work on example 2. Example 2 says sine of x minus pi over 2 is equal to negative sine of x. Well, I'm going to go ahead and start by adding this sine of x over. What I do to one side, I do to the other. So I have 2 sine of x minus root 2 is equal to 0. When I get rid of that root 2, I add it over, so I have 2 sine of x is equal to root 2. And when I divide by 2, I know that the sine of x is equal to root 2 over 2. So this is saying, hey, where on the unit circle is the sine, or the y, root 2 over 2? Well, I know that this is at a 45-degree angle, and they tell us to only answer in the intervals of 0 to 2 pi. So I like to draw my unit circle and think about it. Where is it a positive? Well, y is going to be positive here and here. So I know that this answer will be pi over 4 and 3 pi over 4. And I don't have to name all the rotations because they tell us we can just keep it right there in between the unit circle. All right, let's look at one more. Great job so far. Good old solving like Algebra 1. I'm going to add 3 over. I'm going to divide by 4. And because of that square, I do have to take the square root of each side, which works out so perfectly. Where on the unit circle is the sine equal to root 3 over 2? Once again, I like to look at that unit circle. I know that at pi over 3, we're going to have our sine be root 3 over 2. Ooh, I forgot something. What happens when I take a square root like I did right here? Don't I need a plus and a minus? So that pi over 3 is going to hit somewhere else. I also know that at 2 pi over 3, we have root 3 over 2. The sine will be equal to root 3 over 2. Now, the difference with this one is I am going to answer this. This is a big concept because now, because we have this plus or minus, and only because we have that plus or minus, I have to go ahead and show that it's going to hit here and it's going to hit here. So instead of writing 2n pi, I'm just writing this n pi, because notice that it's going to be a plus or a minus root 3 over 2 at every single quadrant, because the sign will be the same at every single quadrant except for location, location, location changes the signs. But we have both signs, so we can use them. So my answer in this case is pi over 3 plus n pi and 2 pi over 3 plus n pi.